Dear students, I welcome you again to another episode of our conversation on physics. And in this episode, we're going to be looking at, continuation of our discussions on gravitational field. And the question we want to solve that is on the board is from Wyatt and Neko. Past question is a theory question. We want to show a proof. And please follow me as I do this. The question asks us that show that the escape velocity of a rocket is given by velocity of escape equals to square root of 2gr, where r is the radius of the earth. So to solve this question, the first thing is to always recall that force equals to gmm over r squared. We have stated this one on several occasions. So this is the gravitational force, of attraction. And you recall again that work done is equals to force multiplied by distance. We are using r for our distance in this case now. So we now put our f. You can now say work done is equals to gmm over r squared, which is the force of attraction, multiplied by distance, which is r. So one r can go with one r here. So our work done is equals to gmm divided by r. Take note of this as equation 1. Then recall that from the energy conservation, law of conservation of energy, says energy can neither be created nor destroyed, but can be converted from one form to another. And, from the description of the position of an object at different points, from the rest position to being in motion, we agree that the work done is always equals to the kinetic energy if the object is considered in motion, like the rocket we have to prove the velocity of escape for, or work done is equals to the potential energy if the object is at rest. So what we are interested in using now from conservation, from conservation of energy. Okay, so we say work done is equals to kinetic energy. So what is our work done here now? Gmm over r equals to, what's our kinetic energy formula? Half mv squared. So we can say that this m and this m will play out. So we have gm over r equals to half v squared. So when we cross multiply, we can have 2gm over r equals to v squared, where v is equals to square root of 2gm over r. But, we have been told that, note that r is the same as r in this case. So we can write v equals to square root of 2gm over r. This formula, this formula is also very, very correct to calculate the escape velocity of a rocket or of a satellite. But there is a particular one the question asks us to prove, which is square root of 2gr, not square root of 2gm over r. You will now come here. Recall that f equals to mg. And we also have f equals to gmm over r squared. This one, at the preliminary conversation on gravitational field, we'll talk about the relationship between the gravitational constant and acceleration due to gravity, that is the capital letter G and the small letter g. So if you look at this one now, f is equals to mg, f equals to gmm, and since f equals to f, since f equals to f, we can say that gmm over r squared equals to mg, where m can cancel one m, and we can have gm to be equals to gr squared. Gm is air. When we cross multiply, this is like g over 1. G will multiply r squared. Take this one as equation 2. So gm equals to gr squared. If you now come back to this equation that we have obtained, that is escape velocity equals to square root of 2gm over r. And we now have gm equals to gr squared. So instead of gm in this equation, we can put gr squared. So we now have velocity of escape, or escape velocity, equals to 2 over r. Then instead of gm, we put g r square. Since I have said r is equals to r, in this case is considered that way. So we can have our escape velocity equals to 1r, we play out with 1r here. So our final result is going to be 2gr, which is the equation we are given to prove. So meanwhile, for calculation purpose, when you are given a question and you are asked to calculate for the escape velocity, the values or the parameters you are given in the question will determine whether you are going to use this one or you are going to use this one. So when you are giving the gravitational constant value, you are giving the mass of the earth or the mass of the object, and you are giving the radius of the earth or the mass of the rocket or the radius of the earth, you will use this one. If you are the only value you are giving is the radius of the earth and the acceleration to gravity, and you have to calculate the escape velocity, you are going to apply this one. So either of the two are very correct as formula for to calculate the escape velocity of a rocket or of a satellite, so that the object can move beyond the gravitational influence. Lay your hands on many more questions of this type so that you can become perfect in this our conversation. See you in the next